Um, so today you're here for a presentation for a team's project collaboration between or among Jamaica and kids in Nevis and the United States. Our project is called Designing a Curriculum Guide, Assessment Tools and Professional Development around Energy-Related STEM Topics at the Secondary Physics level. And joining us today and presenting Yosier Bagya Maladi, Conroy Hall, and I'm Daniel Alcazar-Rahman, and Safa Bennett will also be presenting. And we have a larger team that some of them are going to be with us as well, maybe interjecting and answering questions. So Dr. Thomas, Graces, Alicia Shaw, Lendrick Lake, Mr. Lake, Austin Strawn, Nisha Foster, Jocelyn Penny Feather, Michael Davis, John Williams, and Eroy Smith. And Bag is going to get us started. Maybe you're muted, Bag, yeah. I don't think we can hear you. Yeah.
Okay, Conroy, can you take over now? Review of our presentation in Peru.
Sure. Will you hear me loud and clear?
Yes, we can.
Okay, beautiful. Well, our topic, as you can see, is based on how we're going to actually use. Could you go back, Barga, please? The impact of STEM teaching modules in terms of conceptual understanding and critical thinking amongst students from grade 12 to 15. And this was supposed to be done in Jamaica, St. Kitts, and Washington, D.C. Can move on here, please. Now, our project, 3 phases. Now, we have been at phase 1, and initially we have started phase 2. Phase 1 was to carry out an investigation among teachers, both in Kitts and Jamaica, and also students. We have already carried out the investigation in terms of the teachers, but unfortunately we have not completed ours in terms of the students. Could you move on, Baga, please? From the investigation in terms of the questionnaire that we administered to the teachers, both in Jamaica and St. Kitts, which was about 8 participants, we observed this from their responses to the questions, and especially when we look at the pedagogical practice used to teachers improve critical thinking among the students in their classes. We found out that most of the response was among the questioning and demonstrating. We find out that in terms of the simulation, it was 27.1 and 39.5 respectively. To move on. Now, what the teachers in Jamaica and St. Kitts say about the pedagogical practice in their teaching and learning question. Now, we found out in terms of what was seen earlier in the graph that 86.4% of the teachers was demonstration and 81 questioning. Based on the literature, we found out that modeling is very important in terms of stimulating students' critical thinking and also conceptual understanding, because they will be able to see a real life application of the concept. In terms of demonstration among the teachers, we found out that the teachers did not use peer demonstration, but mainly teachers' demonstration. Can you move to the next slide, please? In terms of their choice, the choices made in terms of critical thinking among their students, we also found out that in terms of questioning and inquiry-based instruction. The teachers chose those two categories as in terms of what they do in their classes. In terms of instruction and modeling, we see that was 12 and 8%. And the differentiated instruction, we found out from this result that the teachers have a problem in terms of differentiated instruction. In terms of the assessment, in terms of critical thinking, we found out that from the questionnaires that 43% of the participants chose questioning as a part of their form of assessment, and the close end was below, I think, 5 or so percent. One target, please. From all of this, and based on the preliminary route, we intend to have workshops with the teachers in Jamaica and St. Kitts and also in Washington, D.C. So far, we have, in the teachers college, I've started with some students who actually are on 4th-year practice. And from what I'm seeing so far, there is an instrument on the instrument, a tool on the teaching assessment instrument that did critical thinking among students in their classroom, and we found out that it ranges 0 to 5. Most persons are getting below 5. To my analysis of, I think that the workshop would be very, very important among these teachers. In terms of the feedback that we got from and questions we got from Peru, these are the questions. Encourage students to think more about ideas and bring forth their own to add natural rigor to their learning. And this, I have a question. How do you think teachers can encourage the use of the strategies to develop critical thinking? How did you measure the student thinking, which we had a problem with, and I think the seed grant will help us in that area. The level of questioning coming from the students, generating question, or the teachers. I must, especially for number 4, there's an instrument on the tool for assessing teachers which deals with questioning, and I can tell you that the students are getting very, very great in this area. So we think that questioning technique is a very, very important thing that should be a part of the training sessions. Bagel?
Okay, I'm Bhagya Maladi. I'm speaking from Jamaica, and I'm teaching in a high school. I teach the middle school, integrated science, biology, chemistry, and physics. So our goal was to improve STEM teaching and learning and through modeling. So basically, what I did after coming back from Peru is I used my school as a pilot program, and I started incorporating certain things. So our main solution is to do professional development workshops for teachers where they can use cost-effective resources. And I've done that in my classes. So when we have this professional development workshop, teachers can actually see how to use cost-effective resources, easily available resources to make models to strengthen and foster critical thinking skills among students. And our cooperation exchange should help us to develop assessment tools. Now, these are some of the models students have made. These are individual projects and around energy-related topics. This is grade 8, and this is grade 9. They are showing how light rays can be focused to form an image on the retina. And this is a teacher demonstration I did using the lens. So I found that when students are working in groups, there is a lot of collaboration and communication, and that they start really thinking, getting new ideas how to do the project. And these individual projects actually is good for differentiated learning also. So you can help. This particular student had a problem when she was doing this, so I was watching her carefully, and she needed some help. So individual projects are good, and the group projects will help the students to share. These are the what Mr. Conroy Hall was saying, that yes, when students do projects, they can solve real world problems. Here you can see that they are showing one-step energy conversions in all these grade 7 students. So we were asked that how do you think teachers can be encouraged to use other strategies? Now I use a strategy where I saw a website and I posted it to my students and I said, look at the website to make energy conversion models. And you have to make your own, you have to come up with your own models. So they came up with their own models and they were working in pairs. So here they're making party balloons, and here they're showing how a woodpecker moves, potential to kinetic energy, and here they are showing how a balloon can be kept afloat with the help of wind energy. So later when we have the time, I'm definitely going to show you these videos. These are some more videos where students can make models from crash to treasure. So I generally, because we have challenges with resources, so I make them do models with resources that are easily available, like cardboard here and straws, and just water and tubes, and here this was aluminum foil with cardboard. So it's not very expensive, and sometimes they have toys at home, they remove those wheels and all those things and they bring it to class and they make models. So basically what I was trying to do is, modeling was one of the challenges we were having, teachers were not using. So I use modeling like anything from September. I've only been using modeling. And when I see that they have done very well in their test, all my students now are getting about 85 to 90%, and I have all their grades. So I'm very happy that modeling is helping them, because it's helping them to think. But sometimes when teachers see me doing it, they say, how do you get the time? How do they do all this? I said, make them do it in the class as they are learning. So project-based learning and problem-based learning, it measures students' critical thinking skills, and it also generates questions for students and also for us. Now, these are some of the other models in all the other subjects. And this particularly is, I call it like, learn it as, do it as you learn. So as they're learning in the classroom, they are making models. So these are, again, resources where very cost effective. These are cereal boxes. So instead of throwing them away, I ask them to keep it. And then they bring Play-Doh, and then they bring plants, and we did transporting plants. And all these projects are just done in the classroom. And you will see that all these are cost-effective resources. So I can say that it's not difficult to do modeling in the class, and it incorporates a lot of activity among students. These are all individual boxes they're working on in the classroom. These are some of other things they did. They used boxes to make animal cells, and they also started thinking how to give it a name depending on the cereal. They put some information on the sides. All this is their work. I only guide them through. And this is the cell. So you can see that all these models don't require expensive resources. This is again energy related, and this was a very good model made by a student, which I used as a teaching aid. And here they are learning about elements, and so every student was given an element to make an atom, and they did it all in the class while learning. This is food chain, flow of energy. So it shows me that when they make models as they are learning, it improves their thinking skills. Instead of just listening to the teacher, some of them may learn, some of them may not. But through model making, I'm sure they're all learning something, because everybody is doing something at the same time. This is an aquatic chain model. Now, what did we develop? Yes, we developed lesson plans, and our lesson plans are now 5E template. We use the 5E template, and Conroy Hall and we tweaked them to make sure that they were critical thinking questions in the lesson plans. So when I believe that if the lesson plan is designed well, teachers will definitely incorporate all these critical thinking skills, and we can give them ideas they can tweak the lesson plans. That is what I told my teachers. I'm giving you the master lesson plan, you tweak it. So that is what they were doing. Tweaking means they can change the activities, they can change the critical thinking skills, but they have to have them in the lesson plan. And then we have a template. I could show you the lesson plan later. They're all there. You can also see them. And the template will tell you, there's a template where the teachers have to give a teacher reflection and a student reflection too. Now, this is the students in the chemistry lab. They are working with energy-related heating cooling curves. And we contacted heads of science departments of 4 schools now in Kingston, and they are ready to incorporate and take our lesson plans, and they are ready to use them in their classes. And we also told them that very soon we'll be sending them assessment tools so they could use them. And all this has to come through professional development. So professional development is very, very important. So this is all feedback. I had some student teachers who came and to observe my classes for about a week. And they were very impressed because at the end of the class, I asked them, how did you find the class? They felt the students were very much engaged and the environment was encouraging for interactive discussions and sharing of ideas. They also felt that they were manipulating instruments well. They were actually doing graphs and all that. And then the questions that I was asking them and the students were asking me, they said they were very well attempted. So I think that a major problem for me has been solved, which is modeling can help and interactive discussions at the same time. Now, apart from that, what I did was I wanted to really bring this into the school environment. So I started a STEM CCT club. And this is one of our students from grade 12. She was inviting students to come and join the club. So later on, you can hear it. Then this is the rationale. So the club is very active now on Tuesdays. And every time they do something, every time they make a log. So they log and they show me. I'm the advisor to the, I'm the faculty advisor to the club. And this is all that they do. So they have critical thinking sessions where they write their own problems and they come up with a solution. Basically, what I am encouraging them to do is to prepare. They're young innovators. I call them young innovators, and I told them that there's a competition coming up now, national competition, which is Young Innovators Competition. So they want to innovate their own product. So STEM is helping them. So we have about 20 members, and we have the president, vice president, and everyone is there. It's an SVT body. And I find that it has been very useful to have this STEM CCT club because students are going to the club. New students are joining and they're finding it very interesting to solve problems. You can see she's the president. She's teaching them in the classroom. So sometimes they have it in the class, sometimes they have it in the labs, but they're very active. Okay, Daniel, you can take over from here.
Yes, so here I wanted to share some reflections from Washington, D.C. We are ready to release some information, some assessment information here in the District of Columbia that we hadn't had a state level test since 2014. So in a couple of weeks, we're going to be releasing information the student level, school level, and the district level. So we're anticipating a lot of requests for additional support and more about curriculum and assessment development. So we've learned a lot in this project over the last few months. We have been able to see what our common challenges are and how to work together on making better STEM instructional materials that address the needs of students. Can you flip to the other one? So we have new ideas on how to engage students and educators and families, like we have done here with even at the school level with surveys and with students, and it's really going to be helpful for us to see how we can present examples of how teachers can use their own resources and to make them better for improving teaching and learning. Okay, so this one more thing for you, I think, back here. I think the next one. Yeah, flip to the next one. I think that's where we're at.
Okay.
There.
Okay, what is coming up next for the team? You can hear me, Daniel, right? Okay. So what is coming up next for the team is we are going to have mentorship programs for teachers to innovate, to build and to develop portfolios of teaching resources, especially on energy-related topics for middle school. And we are going to help teachers to develop 5E lesson plans. And since the STEM CCD Club is very active in my school and is doing well, we thought that we could introduce it to other schools in Kingston and St. Andrew. I've already spoken to the president and she has ideas that she's thinking of inviting some of the high school students to our school and talk to them about the benefits in the performance of science-related topics if they do have STEM CCD. Then we also have identified the impact of sample lesson plans on teaching, and we want to give them some assessment tools so that we can evaluate how the classes are going on. So we'll be mentoring those teachers.
Yes, and we also have to improve on the units and in what we're working on, we are going to do a corporation exchange experience with collaborating also with the Dominican Republic and at Stanford University. I think we have Graces joining us today too, but we have two outcomes for that experience that are going to help us learn more about research and practice. So the day is 2 days. The day one we're going to spend looking at a program called Science in the City, in which we're going to learn about STEM education, considering aspects of gender, race, ethnicity, linguistics, and the influence of STEM teaching and learning and evaluation. And the second day, we're going to look at a different program that the focus is looking at research and design and advances on implementing formative assessment. Also how to train teachers for them to become better writers or developers of classroom assessment. And we're going to be learning about their approaches for formative assessment, construction, and design, and also how they are able to train teachers at a distance using different methods and modules on the internet. So we're looking forward to learning more about that, and that's going to impact what we're doing in our project as well.
Yes, Mr. Bennett.
All right, yes. And in relation to the seed grant, we want to foster professional development skills in our teachers in terms of translating new learning into practice. And of course, we'll be using devices including the microscience kits. We want to find effective ways of developing this kind of translation. And so we're looking at things like peer mentorship and other strategies that will help our teachers so that when we do training with them, they are inclined to practice, and much of the training will become translated into their everyday practice. We also want to look at ways of assessing the development of critical thinking skills in students. And this will support the project on a more long-term basis, but within a year or so, we should be able to see some good results from the seed grant. Raga?
Yes. Okay, now we come to questions and reflections. Any questions? It's open now.
Excellent. So if anybody has a question, please feel free. We're a smaller group today, so please feel free to just open your microphone and ask your question. I see your hand up there, Gerardo. If you'd like to, go ahead and unmute yourself and ask your question, or you can type it in the chat if you prefer.
Can you hear me?
Yes, now we can.
Thanks, the team. My participation indeed is to give my best work to this team because they use the better technology. They put all the information according. They show statistic. They make and use the mass media indeed. And also, as a question, or my main question is, as a result of the statistic they made, they have a conclusion on this. I say to the whole team or the team who wants to give the answer.
So what was the, essentially you'd like to know what were the conclusions that they came to regarding the results of all the statistics?
Yeah, because I see fully the information they show and the information had been duly indeed. I don't have word to describe the effort that this team have to have made to get this info and produce. I really appreciate that, and I don't have word again to appreciate this higher level of the work. In my personal case, I saw the other presentation, also the Spanish as the other ones, but this one, absolutely is the best one that I saw. Is very interactive, was indeed very informative. So I repeat the question, probably I didn't get this eventually, or didn't have been made my question properly, but I wanted to know that they have, if they have conclusions, and what is the expectation this team have from this point on forward.
Great question, team.
Conrad, you want to answer?
Did you?
Tony.
Yeah.
Go ahead, Conroy, or whoever.
Yeah, indeed, we do have a conclusion. Based on what we found out from the teachers' questionnaire, we found out that the teachers are challenged in terms of differentiated instruction. And as a result of that, what Bagger had done with her students, we realized that we have to use a lot of project-based learning and problem-based learning with relevant strategies that can help the student and the teachers rather to develop better skills to deal with differentiated instruction. To add to that, we are just completing our assessment of fourth-year students who have majored in science, and we found out that in terms of differentiated instruction and questioning, the student teachers also have major problems in this area, and it's because we believe, based on what we saw from the questionnaire result, that the teachers are not able to use the manipulative, such as concrete manipulative and virtual manipulative, very effectively in their classroom, so as to model certain desirable behaviors from their students.
Great. Anyone else?
We also had a challenge with the questioning, because from the teacher questionnaire, we realized that there are more open-ended questions. And so what we did is in the lesson plans were designed in such a way that critical thinking skills are to be used by the students. And so after that, when we set the test, we find that students are really thinking well, and it's not open-ended. They have to think to write a proper answer. So I realized that this designing lesson plans, modeling, interactive discussions, all this has helped us. So I can conclude that where the teachers were using 80% of teachers were using demonstrations, which was not really helping. Maybe the teachers felt that it was helping them because they were questioning. But here I found that when students are working on their own in the classroom, they are developing their own skills and talents, and the teachers can guide them.
Excellent. Thanks, Bhagya. Daniel, we lost your audio. I don't know. We don't have your audio anymore.
Hello?
Yes, Sata.
Oh, right. I'm just thinking whether the question, the person who posed the question, was he satisfied in terms of the response?
Yeah, Gerardo, if you'd like to, yeah.
No, indeed. I'm very happy because the question was very complete, and the exception and the explanation the people did, they are made it very appropriate in the appropriate way. Indeed, I wanted to give the thanks to the participants. This team was indeed fantastic, and the explanation they made properly as any other that I saw during these 5 sessions. Jamaica and the other part of the team, I appreciate your effort.
Thank you.
Yeah, thank you. Thanks a lot.
Thanks you all.
Yes,
Thank
very
you.
kind words. Thank you.
Thank you.
Daniel, I did see that you were trying to share and you didn't have audio. Did you want to go ahead and contribute what you were saying? We didn't hear a thing.
My phone kicked me out, but now I'm on. No, I was just going to add that during the seminar in Peru, we did learn that we should use the resources that we have in our communities, one, and then also there has been a lot of resources around physical science already developed, and they're research-based, and they exist. They just need to be modified and worked on so that they address the needs for our students and teachers. And starting from zero, it's maybe not a great idea.
Yeah, great. There's also a nice compliment here from Carmen. She just doesn't have any questions yet, but wanted to just make sure to express that this has been really helpful for her. You all have shared a lot of important information, and the experiences with your students will also help her in her classes. So thanks a lot, she says. Thanks, Carmen.
Welcome.
Yes. Other questions? Does anyone else have anything they would like to interject? Maybe while we wait for some questions, Bhagya, there was a video. If you wanted to, you're definitely welcome to share that now if you'd like. We have time.
Yes.
Yeah. And anyone in the meantime, if you do have a question, please feel free to either raise your hand using the raise your hand feature of Zoom, or you can put it in the chat. Otherwise, we'll return to questions once Bhagya shows her video.
Okay.
Marie Curie once said, "We must believe that we are gifted with something and that this thing at whatever cost must be attained. STEM CCT in full is science, technology, engineering, and mathematics cognitive critical thinking. Many of the world's leading national superpowers are globally successful due to their skills and accomplishments in STEM fields. Modern discoveries and revelations in science, technology, engineering, and math are precise.
Bhagya, is the video supposed to be showing? I'm only seeing a sound bar.
Okay. I have some. Okay, you can see this one.
I'll be throwing soda into the glass.
So that soda in the glass, she's throwing soda into the glass.
And Mila will be throwing it 6 raisins.
So she's putting some raisins into it. These are grade 7 students.
As you can see, the raisins have been dancing up and down. They aren't really dancing. This is because the tiny bubbles of carbon dioxide inside the soda attaches onto the tiny wrinkles of the raisins. The more bubbles that attach onto the raisins, the more gas there is. And the more gas there is, the lighter they get when they hit the surface. When they hit the surface, some of the bubbles pop, which makes the raisins heavier again as they sink to the bottom. This process then continues to repeat. The raisins have chemical energy, which is then stored as potential energy. And then when the bubbles attach to the raisins, it comes in the form of kinetic energy. So therefore, the energy conversion is chemical to potential to kinetic.
Yes. So that was one.
Very cool.
Yeah. And this was very exciting. It comes up quickly.
Turns mechanical when it reaches the DC motor, and then it pulls the fan spins, and it blows on the ice that's inside and creates movement.
So there was so much of excitement in this. Wow.
What was happening? It was hard. The video was a little bit, the signal was a little short. What exactly was happening, Bhagya? Could you explain it?
Okay, there was a motor inside. They put a motor inside with a fan. The motor was connected to the fan, and then they had ice inside. So when the motor turns the fan, then there's cold air coming out from this outlet. So they are showing wind energy, conversion. It was very nice. And this is the third one. These grade 7s come up with ideas. They were showing electrolysis, electrical energy. They use pencils. You can see the gas. So, they come up with their own ideas. Like they had to come up with their own ideas, questions, and it was nice to see them. Now, this student, she made this model, and she used hydrostatic pressure here. just with cardboard and straws. This was her model to show potential to Canada.
Wow, that's good.
And then this student now, she made a so it's exciting to see them coming up with their models, and they are so excited about their own. They feel that they have become inventors, and
Yes.
yes, it
Oh,
gives
that's
them a
great.
good feeling. And this is they were trying to make party balloons. Vinegar and baking soda. So there was vinegar in the bottle, and they added baking soda to it, and carbon dioxide gas coming out. They were filling up balloons.
Very good. I have only seen a volcano, but now this is a new idea, right? Party balloons.
This now they're keeping this balloon afloat with the help of wind energy from this gun. Yeah. So these are all energy conversions. They're just introduced to energy.
Thanks so much, Bhagia, for your sharing.
Sorry, Alison?
I said thank you for sharing those. I mean, that's very great.
Oh, you're most welcome.
Such a great addition to all the work. If anyone has any questions, we do have a few more minutes that we could take questions about any of the work or any comments as well. Please feel free to open your mic, or you can type them in the chat.
We have some questions. If they have finished with their questions, we can ask them a few questions.
Sure.
Okay, these are our questions. What are the changes you observed to show that the teacher moved away from the traditional method of teaching by using the chalk and talk method?
And what is the chalk and talk method?
The traditional way of teaching.
Okay.
I call it chalk and talk.
I like it.
So, and the other question is, what are other ways the instructional time could be wisely used by the teacher? Then please comment on the lesson planning to foster a learning environment for students, conceptual understanding and critical thinking skills. What are the other cost-effective resources the teacher could have used for the teaching learning process? How did the students with different learning styles benefit from the lesson? What could the teacher do differently to improve the impact of modeling exemplary STEM instruction? So,
yes, if anyone has any comments or has an answer to any of these questions or thoughts, please feel free to contribute. All right, I don't see any questions coming in. Team, are there any final comments that you all have? Any thoughts before we tie up the end of this presentation?
Alison?
Yes.
I just want to say that working with the team has been a very, very rewarding experience to date. This kind of research, I've always had great interest in it, and I think we have a great team of persons that just come together and have just fitted in a way that we're able to seamlessly conduct this research, and with it comes a lot in terms of the developing skills and creativity, and we feel empowered to share. And I think the greatest thing coming out of this project is really building of our capacity and bringing out that which we didn't think we had. And we want to share with others. And I think this is a great experience for the team.
Yes. Thank you, Mr. Bennett.
And I would love to thank OS and ITEN for giving us that exposure at Peru. I think that exposure at Peru really changed my way of thinking. Like, I really can't think of going to a class and just, teaching the students. They have to do something. We have to be active. Even today, the grade 7s were so excited, and because I told them I'm giving them merits for some things in group, they were working. So I think that the Peru experience was very good, and we working in groups of 6. I think that gave me a very good experience. It opened up my eyes really, and I know where I fell behind, and I'm trying now. I still know there's room for improvement, and we can do it. So thank you, Alison, and the ITEN team and OS.
Yes. Well, thank you. And just so the rest of you are aware, the Peru experience that they're referring to is our annual seminar. So that's the time where the project teams actually come together in person and get to work together face to face to continue their projects. Right. Yes, thank you, Carmen. I see your comment here. She said, I can't wait. I'm really excited to apply all this knowledge with my students. Thanks a lot again. Thanks for coming, Carmen. Carmen's been at several of ours, so thanks for joining us, Carmen. Excellent. Okay, well, if there are no other final words, team,
Well,
speak
thank
now.
you so much. Thank you to the staff, too, for helping us get organized, especially you, Alison.
Of course, it's been my pleasure. It's been so wonderful to work with all the teams and see all the work that you guys have done in the last 6 months. It's amazing how far you can come. Also reminds us of how far we have to go.
Yeah.
But it's great. Of course, it's my pleasure. Well, I'll go ahead then and close out here. So I'm just going to share with you the last couple of slides that I have for everyone. Carmen has seen these several times, so has Gerardo, because they've been at most of the webinars. But just for the rest of you who have not been here, we would really love your feedback. So let's try sharing again. Can you all see my screen here?
Yes.
Excellent. Okay, so everyone, you should have received an email already, actually in your inbox, to complete a quick little 5-minute survey for us about the webinar and this information. And then just so you know, it was recorded, and so everything will be posted online on our website, and you'll have the link to that in the email as well. And then just one last note, I forgot to delete these here before because we've already completed these webinars. But the December 10th webinar in English is at 12 p.m. and then in Spanish at 2 p.m. Eastern time in the US. That will be our project team informational webinar. So please come to that if you're curious about how to get involved with these awesome teams and be a part of it, and come to our annual seminar. All right, I think that is everything.
Okay.
All right, so thanks again, everybody, for coming. Thank you, team, for being so amazing and doing so much work and putting all the effort into this and listening to me go on and on about things all the time and trying to get you all to work more with me. You did a fantastic job. This was so much fun. I look forward to what the future holds and the Cooperation Exchange and Seed Grant. Really great work. Thanks, everyone, for attending. Everyone have a beautiful weekend.
Thank you.
Thanks. Take care. Bye, everyone.
Bye. Thanks.